Good day, students. I hope I find you well. Today, in this chemistry section, we're going to talk about redox reactions. We want to define what are redox reactions, what are the examples of redox reactions that we can have, and why is it that we say reduction and oxidation, they occur simultaneously in a chemical reaction. So, if we look at this word redox, it is a combination of reduction and oxidation. Okay, so this word redox is actually built by the terms red and ox for us to have a redox. Okay, so in simplest terms, when you are saying oxidation, it means you are adding oxygen, and you are saying reduction, you are subtracting oxygen. So in simplest terms, that's how we can look at oxidation and reduction. Oxidation, I am adding oxygen. Reduction, I am removing oxygen. But we can also define oxidation and reduction in terms of movement of electrons. Okay? What you simply have to remember, students, is we can use this. Okay? Oil rig. Okay? Oxidation is loss of electrons. Reduction is gain of electrons. So we can add here, when we add electrons, okay, that's reduction. When we remove electrons, then that becomes oxidation. So it's opposite. Whilst reduction is removal of oxygen, we are adding electrons. Whilst oxidation is addition of oxygen, we are removing electrons. That's basically what we are doing here. We have looked at the definitions. What is left for us is to study redox reactions. Okay? Suppose we pass hot hydrogen, okay? Or we pass hydrogen over hot copper 2 oxide. What are we going to observe? Okay? We have copper 2 oxide. Okay? That's our equation. Copper 2 oxide. Let me use another marker. Okay? Copper 2 oxide is a solid, and we are going to pass hydrogen. Okay? What? Copper 2 oxide, we pass hydrogen gas over that powder. What do we observe? Okay? We're going to observe a brownish gas, a brownish solid rather, being produced plus water. Okay? And our water will be liquid. Now, let's look at what is happening here. Okay? You see that there is movement of oxygen. The copper oxide has lost. Okay? If you are looking at what has happened to the copper oxide, all right? Copper oxide is now copper, meaning to say we have removed oxygen. Okay? And if you also look at what has happened to hydrogen, okay? Our hydrogen was H2, now it is H2O, right? So you see what has happened to hydrogen. The oxygen which was lost by copper oxide was gained by hydrogen. Okay, so the hydrogen gains oxygen. So here we say plus oxygen. All right? So in essence, what are we saying? Our copper oxide has lost oxygen, so we say the copper oxide has been reduced because it has lost oxygen, and our hydrogen has gained oxygen. Therefore, our hydrogen here has been oxidized. Okay, so in this process, we are having a reduction and oxidation taking place at the same time or simultaneously. As a result, this reaction shows us a redox reaction. Copper oxide plus hydrogen, we have copper and water. In this reaction, you're actually going to find out that the heated copper 2 oxide it was black. This is a black powder, and this one will be a brown solid. It confirms what we study when we say chemical reactions, chemical change are always accompanied by change in physical appearance. Okay, and I said we are using hot copper 2 oxide to convert it to copper metal. Chemical changes are always accompanied by the presence of heat. Either heat is taken in or heat is taken out. So this reaction shows us an example of a redox reaction. This is an example of a redox reaction in terms of movement of oxygen. Now we want to look at redox reaction in terms of movement of electrons. Okay, right. So we want to look at another example here where we are focusing on a redox in terms of movement of electrons. Okay, let's keep it simple. Let's just look at this example. Let me find a better marker here. Okay, let's look at a very simple example. Okay, magnesium solid is going to react with oxygen gas. Okay, and then we produce magnesium oxide solid. Okay, right? Just need to balance our equation here. Just need to balance our equation. All right, as before, right? 2 atoms of oxygen, 1 atom of oxygen. So we put a 2 there. When we put a 2, the coefficient 2 is also going to affect magnesium. So I go to this side of the equation and I put a 2. Okay, a quick check. 2 atoms of oxygen, of magnesium, and 2 atoms of magnesium. That's okay. 2 atoms of oxygen and 2 atoms of oxygen there. That is okay also. So our equation is balanced. Okay, but what is happening here? When we are looking at this equation, okay, look at these elements, they are neutral, but let's look at what is happening, okay, in this ionic compound. Our magnesium is going to be +2 and -2, okay? Oxygen was neutral here, is now charged. Magnesium was neutral there, is now charged, okay? So we want to trace it, look at what has happened here. What should happen for us to have magnesium being converted to magnesium +2? What should happen for us to have oxygen converted to oxygen -2? Okay? For us to have a neutral element becoming a positively charged ion, it means it must lose electrons. Okay? So there is here loss of electrons. Loss of electrons. Okay? If there is loss of electrons, that is called oxidation. Okay? Now, oxygen is going to gain electrons, that becomes reduction. Okay? So, again, this is an example of a redox reaction. But we can split this story into 2 parts. Okay? We want to trace, we want to look at what is happening. We want to look at magnesium separately, we want to study oxygen separately. In other words, I want to look at what is happening to magnesium separately and what is happening to oxygen separately by writing what we call half equations. Okay? So magnesium was magnesium metal and it lost 2 electrons. That's how we write the 2 electrons. Magnesium 0, now +2, it means we have lost 2 electrons. Okay? That's the first half equation that we can talk about. Okay? We can also look at what happened to oxygen. Okay? We had our oxygen here. Okay? And our oxygen actually gained. Okay? Our oxygen actually gained 4 electrons. And then we actually going to form 2 oxide anion there. Now you need to understand the fact that if we have half equations and we add our half equations up, we will be in a position to come up with the original equation. Half equations are just there to show us, okay, what is happening to each element. Okay, so for the reaction above, the half equations will be magnesium forming magnesium ion plus 2 electrons, and then your oxygen forming your oxide ions there. Okay, so reduction and oxidation always take place together in a reaction. So the reaction is classified as a redox reaction. There are many more examples of redox reaction that we can talk about, but I've just shown you one type here. I hope you've had a very good introduction to redox reaction. Okay, if you open textbooks, you find out that whenever there is loss of electrons, okay, we are going to classify that as oxidation. Whenever there is a gain of electrons, and then we are going to classify that as a reduction reaction. In essence, this is a redox reaction that we can have a look at. I hope you've managed to understand oxidation in terms of movement of oxygen and also movement of electrons. Thank you. Just remember to subscribe to my YouTube channel and also to share this video if you are benefiting from a series of videos that I'm producing, so that at the end of the day, not you only will benefit, but also your friends, and that will help to increase your grade in exams. Thank you. Bye for now.